Okay, YouTube, in this video we're going to look at another matrix operation called scalar multiplication. I do want to say this, at least if you tuned into my last video here, I said that the only two operations that are defined with matrices are addition and multiplication, and I failed to mention that the third operation is scalar multiplication, and that's what we're going to talk about in this video. But the reason why is because, I was kind of mentioning that we add, subtract, multiply, and divide with real numbers, and there is no scalar multiplication with real numbers, so I kind of left this one out. But here we go. We say scalar multiplication. If we have a scalar c, and we say that a scalar, basically a scalar is a real number, and I'm going to say often multiplied by. So sorry for ending with the preposition here and putting that comma, but basically scalar is a real number we often multiply an expression by, and what it does is it scales things, okay? So we can multiply a matrix by a scalar by multiplying each individual entry of the matrix by that scalar. So that is to say, where it says CA right here, let's rewrite this again. We say that if I took a real number C times a matrix, and this matrix contains a lot of entries that are in the ith row and the jth column of that matrix, basically what we're going to get is this new matrix where every entry in the every entry A in the ith row and the jth column would get multiplied by this number. And so another way to look at this is basically it's just distribution. That's all it is. Okay, so we're going to take a look at a couple of expressions here we're going to evaluate. We say we have two matrices here, A and B. And so in this first example, we want to find negative 2 times B. So where it says negative 2 times B, by the way, B is this 3 by 3 matrix right here. We're just going to basically scale this matrix by a negative 2. So I'm going to put a negative 2 out front. I'm going to rewrite this whole thing as negative 2 times B, which would be this right here. 1, negative 4, and 3, and negative 1, 3, and 2. And because we're just going to distribute this throughout, what we end up with is this new matrix where everything in here gets multiplied by the negative 2. So we get negative 4 here, but 0 and 0 there. Let me put a purple bracket there. And then we say negative 2 times all of these. Well, that would be a negative 2, but a positive 8 and a negative 6. And then a negative 2 times this last row here would be a positive 2, a negative 6, and a negative 4. So this would be our new 3 by 3 matrix that would be equal to negative 2b. That's what that would be right there. Now looking at this next expression, 3a minus b. Now recall from my last video when we talked about matrix addition. Matrix addition is what is defined, and subtraction is not truly defined. So what we're going to do is we're going to rewrite as addition first. I'm going to make a little note here, as addition. Take my time here, addition first. I can squeeze that in there. Exclamation point. So we'd say 3a minus b is the same thing as 3a plus a negative 1 times b. So when I rewrite this here, I'm going to say, well, 3a, let's take a look at 3a here. That'd be 3 times 2 times 2 times 4 in my first row, negative 3, 0, 1 in my second, and 2, 1, 2 in my last. Positive 3 times a plus negative 1 times b. So our b matrix here is this. In other words, we're adding the opposite of matrix B, which would be the same thing as kind of what we think about as subtraction with real numbers. So let's go ahead and simplify these expressions here. I suppose if we scaled these entries up, tripled them, we'd say 6, 6, and 12 would be the new entries here. We would have negative 9, but then a 0, but then a 3, and then 6, 3, 6. And then this matrix here, when we make everything its opposite, we have negative 2, 0, 0. We would have a negative 1, a positive 4, and a negative 3. And then here we would have a positive 1, negative 3, and a negative 2. So adding these together, these two 3 by 3s, I would get a new 3 by 3 matrix. So let's go ahead and write its sort of skeleton down here. And we'll just add entry-wise. So we say 6 plus a negative 2, well, that would be a positive 4. 6 plus a 0 is a 6. 12 plus a 0 is a 12. Now, negative 9 plus a negative 1 is a negative 10. 0 plus a 4 is, of course, 4, and 3 plus a negative 3, not 3 minus 3. Got to be careful how we interpret that. We say 6 plus a 1 is a 7. 3 plus a negative 3 is a 0, and then 6 plus a negative 2 is a 4. So this would be our expression here that is equal to 3a minus b when we do this operation. So the last thing I want to do here is that I've already had these two matrices typed into my calculator for matrix A and matrix B, and they are located here. What I want to do is evaluate these using my calculator as well. So if I had done negative 2b in my calculator, I would have just written negative 2, go into our matrix menu, and we'll pull out matrix B here, and I'll hit enter. And you can see that, of course, is the same set of entries that we got in this matrix we did by hand, but it should be. But you can check it on a calculator. Lastly, this expression here, 3a minus b, we'll go 3, pull out matrix A, and we'll say minus matrix, and we'll pull out matrix B. So 3a minus b, you can see, of course, also that we got these entries down here. So that's what we mean by scalar multiplication and how we can use it to help evaluate differences in various expressions. Cheers.